Start that again. Good morning, everyone. You're very, very welcome to the launch of the Dublin Region Energy Master Plan. It is really great to see you all here this morning and wonderful to see such a big turnout and interest in this piece of research. So just to introduce myself, for those of you who don't know me, my name is Katie Harrington. I'm the Energy and Climate Awareness Officer with Codema. So I'm sure many of you are aware of the work that we do in Codema, but just for the benefit of anyone here this morning who isn't so familiar with who we are and what we do. So we were set up back in 1997, so we're going 25 years now, and we act as the energy agency to the 4 Dublin local authorities. So we provide a range of services to the councils, essentially to help them meet and even exceed their energy and climate targets, and to really lead by example in the work they are doing. So these services include helping with energy monitoring and management of council buildings and facilities, project procurement and implementation, such as district heating and energy performance contracting, awareness and engagement activities, such as our award-winning Home Energy Saving Kit scheme and our Zero Together initiative. We also provide management support in terms of drafting and managing national and EU funded projects so that we can bring innovation and learning to Dublin. And then last but not least, our research development and innovation team covers areas such as national and EU energy and climate policy, modelling of greenhouse gas emissions, and of course, energy master planning, such as the Dublin Region Energy Master Plan, which of course is why we're all here this morning. So by way of a very succinct introduction to the Dublin Region Energy Master Plan, it is the result of 3 years worth of research by Codema's energy planning team to identify the greatest potential to reduce emissions related to heat, electricity, transport, and buildings in Dublin. Put very simply, this means that the master plan has looked at what should go where for every part of Dublin based on the type of area it is and the technologies that are best suited to reducing energy related emissions within that area. Also, very importantly to say, it was funded by the SEAI through its research development and demonstration funding programme that we applied for in 2018. So I'm sure you're all very ready to hear the presentation, but just before I hand over and introduce our Energy Master Plan team, I just want to very briefly go over some housekeeping items. So just to let you all know that this event is being recorded, and of course we will circulate this recording and presentation afterwards. Just so everything is nice and quiet during the presentation, we would kindly ask that you just check that your microphone is on mute. So yeah, if you could just check that, that would be great. The presentation from the team is going to last about 45 minutes, and then we'll have a Q&A session for about 30 minutes at the end. So if you do have any questions along the way, please feel free to pop these into the Q&A box, which you'll see at the very bottom of the screen, and we'll compile them as we go. If you do like someone else's question, there is a function to upvote, so please feel free to use this and we can then prioritize questions. And then in a bid to get through them as efficiently as possible, we would ask that you keep to questions rather than comments in the Q&A box, just so it's easier for us to read and collate all of the questions coming through. And also, if you are tweeting about the launch this morning, if you could please tag at Codema Dublin, that would be great. So without further ado, I'll introduce our Energy Master Plan team who have been doing all of this great work over the last few years. So giving the presentation today is John O'Shea, who is our Energy Systems Analyst and the lead on heat and electricity. We also have Rebecca Katia, who is our energy engineer and the lead on emissions and energy efficiency. We have Owen Ahern, who is our energy manager and the lead on transport and renewables. And then finally, Kieran Murphy, who is the lead on our research development and innovation team, who joined us December last year. So John, I believe you're kicking things off, so I'm going to hand over to you now to begin the presentation.
Great, thanks a million, Katie. So yeah, just I suppose say, yeah, so the reason we're all here this morning, as Katie said, is to introduce the key findings from our Dublin Region Energy Master Plan, which is, finding that cost optimal pathway to decarbonising Dublin. So just to, by way of a bit of an overview, so this research is the first of its kind in Ireland. So it's building upon international best practice, primarily from around Europe. And we're hoping that by adopting this in Dublin, we can act ourselves as an example for best practice for other regions in Ireland to follow. And the way we've approached the master plan as well will hopefully help facilitate that too. So we're looking at the cost optimal pathway to our 2030 and 2050 targets. And to do that, we've created this kind of holistic integrated energy model, which looks at, all the energy sectors. So we're talking heat, transport, and electricity, and, the interaction between these as well. And also considering the local kind of technical and spatial constraints. I suppose the model itself essentially is a digital twin of the local energy landscape. So it's already beginning to be used as an evidence base to inform policy at a local level, but also for infrastructure planning in things like district heating networks and on the electrical side as well. So it's, I suppose, what kind of differentiates the plan from a lot of other models as well is that it's spatially led. So as Katie said, it's the what should go where, not just the what. So I suppose that kind of takes into account the topographical and the spatial constraints, in each of the roughly 5,000 small areas in Dublin. And we also consider the wider social and economic impacts as well. So things like, employment opportunities, health, fuel poverty, and affordability. So we've got a section on that as well in our work. Just to chat about where it fits into the policy, I suppose, at the national, regional, and local level. So at the national level, this allows us essentially to chart the greenhouse gas impact of the plan and assess how we're progressing towards our plans, or how we might progress towards our plans, and also outlines the contributions that could be made by certain regions to national targets. So we've got national targets for number of heat pumps. We can say, oh, we think Dublin can contribute X number of heat pumps to that plan. Or the national target for district heating, we can say Dublin can contribute X terawatt hours or whatever to that plan. And then at a regional level, so it kind of answers or is a response to a number of regional policy objectives. So things like feasibility for district heating, identifying zones for sustainable energy zones for large scale renewables, and then at the local level, as I said, it's used as an evidence base for things like our climate change action plans, informing county development plans, identifying decarbonisation zones, which the local authorities have to identify as part of their remit, and then also it's kind of an online data source that can help support sustainable energy communities as well in their own kind of more local master plans. So yeah, I guess the potential, I guess, for supporting decarbonisation into the future via the master plan. So as I said, we kind of have some online data and maps that the SECs can avail of to help with their own master planning work. Kind of providing that feedback loop into national policy in terms of what are the regional constraints and contributions that can be made. Also, increasing engagement with citizens and stakeholders. We've got plans. Hopefully, the maps that we have now can be added to in terms of increasing engagement and allow, if you're being told that your neighbourhood is suitable for PV, we can signpost you where to go on that, or you can register your interest, and there's kind of a line of communication there, and then that can also, we can start to group people together as well into kind of batches to help, I suppose, to reduce the admin of making all these projects happen, and avail of kind of economies of scale by doing that as well. And as I said as well, it can also act as an evidence base and a sort of a screening tool to kind of mobilize green investment, so help people decide where they might look to invest their monies. I suppose, just to say as well, so the model models each of the energy sectors, but also how they interact with each other. So it allows us to answer questions like, what areas are suitable for certain technologies, but also, say in the case of district heating, how can that support the electricity grid? So district heating, obviously, you can have really cost-effective large-scale storage in terms of thermal storage, which is a fraction of the cost of batteries. How can that support a more renewable grid, or how can EVs be used to support a more renewable grid by using their batteries when they're not in motion, essentially. And also things like, if you improve the energy efficiency of buildings, how does that impact on the the heat demand, or will it also creates more opportunity for waste heat to be used as well through the cooling system. So it's trying to model all these different interactions. So the process then, I won't go into a lot of detail on this, but just to give an overview. So the modeling process is basically, we started with a current situation, so kind of what exists now, and then kind of projected kind of business as usual case, which is basically taking the current situation and projecting it into the future, for things like increases in population, upcoming building standards, things like that. And then I suppose identifying the potentials then based around the kind of local constraints. So the local constraints for each technology, and then using that to inform our kind of optimized pathway to achieve our targets. I think it's important to say as well that one of the main motivations around how we address the master plan is that we didn't want it to be a report just gathering dust on a bookshelf. So we kind of wanted it to be interactive and open for use and interrogation by others. So to do that, we kind of prioritize the use of open source tools. So a lot of the work that we've done has been done in Python, where the code is available online on our GitHub repository, where other regions can use and avail of that resource. We have a lot of online resources and maps, which the general public can look at and say, oh, my neighborhood seems to be suitable for this certain technology. So increasing engagement in that way, and then also making the data we have available for other research groups in academia, so that, like, we've done a lot of pre-processing of data in the master plan. So we've kind of done all this work, so we want to make sure that others don't have to go through that same step, so they can kind of start their research from the point of doing the research rather than the point of gathering data and cleaning data, which is always a significant amount of time for anyone who's worked in the area. They know that well. And then also we're kind of already starting to use the master plan to inform local policy. So that's kind of our plan, that it will continue to be used, by local authorities, etc., to help inform their local policies. I think it's worth mentioning as well that we kind of collaborated with a lot of different organizations in putting this together. The 4 Dublin local authorities, we've got a residential energy modeling group that we're part of as well, that helped input into our some of our models, engaged with ESB, the NTA and all these groups to help inform this. So it's trying to bring all those strands together into one path. I suppose that kind of novel approach of making it as open source as possible. So we've kind of used as many open source tools as possible so that others can replicate. So all the open source tools in this schematic here are the ones that are freely available and open source for others to use. So it's just to kind of highlight that, we try to make it as replicable as possible. And so I'll just hand over to Rebecca now to chat to you about that situation.
Yeah, thanks, John. Good morning, everyone. So I'll be going through the building sector current situation. And as John mentioned in the master plan process slide, we need to understand our current energy and emissions before we can move on to our pathway and the low carbon solutions to meet Dublin region's 2030 and 2050 targets. So the building sector is broken down into residential and non-residential buildings. So for the residential sector, we built a synthetic building stock model that can model each individual residential building in the region. And from this, it was found that the housing stock is an aging and poorly rated stock, with 78% of the stock having been built prior to the year 2000. And since the housing stock is an aging stock, it also impacts the energy efficiency of the dwellings as well. So the map there on the left shows the Dublin region broken down by small areas. So a small area is essentially a small geographical breakdown that's used in Ireland for statistical purposes. So in that map shows all the average BERs, essentially the building energy ratings for each small area. And in Dublin, the most common BER was found to be a D2 rating for the year 2021. Buildings rated D1 or worse made up 58% of the housing stock, whilst A and B rated buildings only made up 12% of the stock. Then moving on to the non-domestic buildings. Thanks, John. So the non-domestic sector includes commercial, so that's the likes of retail, offices, restaurants, all the public sector buildings and industrial buildings, excluding non-ETS buildings. So in this project, we've analyzed over 30,000 commercial properties, and the total energy demand from non-domestic buildings is coming from commercial buildings and services. They make up 65% of the demand, followed by the public sector and industrial uses. So for the public sector, we've made use of metered energy consumption. So this is all data that's coming from the monitoring and reporting through the SCAI's tool. And from this, we could find that healthcare buildings emitted the most CO2, followed by education buildings, offices and other buildings. For commercial buildings, we made use of benchmarks. So that's really using an energy use per meter squared floor area. And it was found that storage facilities were emitting the most emissions. So that's the likes of warehouses and bulk stores used for retail, offices, and leisure categories. And then for industrial emissions, we made use of industrial annual emission reports from the EPA. So this provides us with metered energy demand for large scale energy buildings. Next slide there, John.
Thanks, Rebecca. Yeah, so the current situation in heat then, so I guess just to say that the total heat demand in Dublin is just over 10 terawatt hours. And you can see on the right-hand side there, we've kind of provided a breakdown of where that heat's coming from essentially. So it's predominantly natural gas, followed by electricity. So that's mainly direct electricity rather than heat pumps, and then oil kind of coming in third there. And you can kind of see as well with the electricity that predominantly that's in the Dublin city area. So that's due to the fact that there's a lot of apartment blocks that would have, direct electric heating as opposed to homes rather than apartments. So yeah, gas is the predominant source for heating in the Dublin area, and it covers about 70% of the installations, but about 90% of the heat demand. Yeah, I suppose it's worth saying that these the heating systems in Dublin are predominantly individual heating systems as well that heat each individual building. Just on the electricity side, so you can kind of see that the breakdown of electricity demand. So it's probably predominantly in the residential sector with 57%, then commercial, followed by public sector and industrial. And you can kind of just see the maps on the right-hand side there. So we've kind of mapped out essentially the electricity grid for Dublin, and kind of put together this kind of down the bottom right, this kind of capacity map, which kind of shows constraints on the electricity grid, and we go into what that's used for in later slides. Cool. That's over to you.
Thanks, John. So just looking at the transport situation for Dublin at the moment, on the left-hand side here is the map of emissions per road link in the Dublin region. So for this analysis, we were provided with data from the NTA from their East Regional model, and the outputs from that in terms of emissions, and they also provided us with data in terms of the number of kilometers traveled by each mode of transport in their current situation and projected out to the future as well. So on the left, it's this map just shows the emissions per road in terms of tons of carbon dioxide per kilometer. So you can quite clearly see that the heavily traffic routes like the M50 and the major arterial roads in and out of the city there are quite high on that scale. In the middle up there, this just gives a breakdown of the emissions per vehicle type. So in Dublin, private car makes up approximately 65% of energy demand and emissions from transport. Then light good vehicles, so that's kind of vans and light trucks, makes up 12%, followed then by heavy goods vehicles at 15%, and public transport is relatively small in comparison, so 5% of emissions from buses and 2% from passenger rail. Rail freight is almost non-existent in Dublin. There's only 2 routes, I think, in and out of Dublin Port. So it's yeah, very, very small on that scale. And then on the right, this kind of looks at car ownership levels in the county. So the number of cars per 1,000 adults in each of the small areas. So if we go to the next slide, John, please. Zoom in a little bit better. So you can kind of see as you get into the city, quite low levels of car ownership, but in the suburbs, particularly the south suburbs, quite high levels of ownership, and further out into kind of rural areas, you might have as high as 800 cars per 1,000 adults in certain areas of Dublin.
Yes, so now moving on to our current situation. So looking at our total emissions, and I suppose once we get an understanding of Dublin region's total emissions, then we can look to identify the gap, Dublin region's gap to target. So currently Dublin's emissions account for 5,700 kilotons of CO2. Heat accounts for the majority of emissions within the Dublin region at 46%. Followed by transport and electricity. So when comparing these figures to national statistics produced by SCAI, heat emissions for the Dublin region are higher than the national share. And this really is due to the high building density in the region and also the aging housing stock. Emissions for electricity have reduced over recent years as more renewable energy is used for electricity generation. Then looking at transport, so for transport emissions, the emission share for the Dublin region is slightly lower than the national share. And this can be due to the high density of developments, meaning that in the Dublin region, there are shorter distances to be traveled, as well as access to higher quality public transport, walking and cycling facilities when comparing to the rest of Ireland, that is. So then if you have a look at the sorry, previous slide, please, John. Then if you have a look at the chart at the bottom there, so the bars in blue show Dublin's historical emissions. The green bar there essentially shows our current emissions. So that's the results from the Dublin Region Energy Master Plan. The shaded bar in green is the Dublin Region's 2030 target. And then we have our 2050 glide path, net zero glide path. So the current gap to 2030 target amounts to 2,856 kilotons of CO2. So that means a 48% reduction in emissions is needed to meet the 2030 target from 2021. Then essentially it's 100% reduction in energy-related emissions to meet the net zero energy-related emissions target by 2050. So then moving on to our challenges and barriers and getting a sense of what the key issues are to meeting the Dublin region's targets in 2030 and 2050. So for the building sector, the barriers to building upgrades can be attributed to a number of different issues. And most of these barriers are common to both residential and non-domestic buildings. So from Codema Zero Together survey, participants who responded to the survey highlighted barriers such as cost, poor infrastructure, and also lack of information and awareness as being key barriers to those living in Dublin to take direct action. So looking at costs, So one of the key constraints certainly is costs and a restraint to retrofits, that is. So the map there on the left shows the deprivation index for small areas in the Dublin region. So essentially, the deprivation index helps policymakers and researchers to identify areas that are potentially disadvantaged areas. So the areas with which are highly affluent are shown as green, and least affluent areas in red. We've also taken into account in the master plan consumer behavior and consumption practices. So looking at cost and long payback periods for retrofits, it makes it difficult for customers to buy in essentially into upgrading their buildings. And this is even more so when you take into consideration consumer behaviors and consumption practices. So in general, higher rated buildings tend to use more energy than predicted as occupants become more used to the higher comfort levels. So essentially, because of warmer homes, people might tend to change their normal patterns. For example, start opening windows or start wearing shorts, for example. So you're not really seeing the full effect of the building upgrade. We also looked at home and business tenure. So a key issue in Dublin certainly is rented property. So rented accommodation and business properties, with essentially the building owners having very little incentive to invest in costly measures to improve energy efficiency. And this is really because they don't directly benefit from the energy efficiency upgrades. So the map there on the right shows the percentage ownership by small area, with the areas in green showing the areas that are rented out and the red areas are owned outright. So the lowest home ownership can be found in the inner city area, and these areas overlap with areas that have a high number of apartments. So say, for example, if we look at Dublin 1, 2, 7, and 8, 52% of all the residential buildings are apartments. And these same areas also have poor BERs. So for the same area, the building energy rating is 68% of the housing stock having a D1 building energy rating or worse. Therefore, we've identified these buildings, these inner city apartments, as being some of the hardest to retrofit. We've also looked at protected structures, so looking at heritage buildings. So we've identified over 420 heritage buildings in the Dublin region. And depending on the nature of the structure and the features of interest, sometimes even work such as painting of the interiors or replacing windows can affect the character of the structure. So for the purpose of the master plan, these buildings were not considered suitable for energy efficiency upgrades then. Next slide there, John, please. So one of the key questions was where to start, which areas to tackle first, and how to alleviate, I suppose, the issue of energy poverty in specific areas. So to assess, I suppose, energy poverty and to identify these areas that are in need of retrofit upgrades, we've combined together BERs. So we've looked at BERs with a rating of D1 or worse. We've combined that with a high unemployment, so great unemployment of greater than 20%, and a deprivation index of less than -10. So that would mean it's a disadvantaged area. And from this, we can identify, I suppose, the energy poor areas. So it's identifying these areas which we should tackle first, which we should prioritize for incentives. And we have this tool online as well on our master plan website. So we'll share all the links then at the end of the slides. Next slide there, John, please.
Thanks, Rebecca. Yeah, just to chat about the challenges and barriers on the heat sector then, I suppose. So some of the main barriers to decarbonising heat, which is, you know, currently the the worst performing sector in Ireland. So some of these are the high capital cost, and I suppose also the cheap cost of gas. You know, well, it's not cheap anymore, but relative to electricity, it's cheap. Also, the kind of suitability of buildings to adopting heat pumps. So on the left-hand side there, you can see there's the green map. So this is basically a map that we've done of the percentage of dwellings that are suitable for heat pump adoption. So we base that on what's called the heat loss index, which is kind of a measure of how leaky your building is. And so in order to secure a grant for a heat pump, you need to have a heat loss index of 2 or lower. So this kind of shows the percentage of buildings that would be able to avail of that grant, which is one of the kind of main barriers to adopting heat pumps is the upfront cost. So access to grants is a key consideration there. Another key consideration is the cost of the electrical grid upgrades to electrify the heating sector. So on the right-hand side, we have our capacity maps, which basically show the available capacity in the electricity grid, kind of broken into different regions in the county. So essentially what we've done is we've taken an average cost of grid upgrade, say if you're installing heat pump or an EV in your house. So we've got a euro per kilowatt figure, and we've kind of adjusted that figure up and down depending on how much capacity is remaining in the grid in your area. So to try and take account of the varying constraints across Dublin in terms of the grid. And then the other one is being able to maintain efficient operation and a high level of service is another key barrier. So traditionally there's a lot of putting boilers up on walls, and whoever puts it in just walks away and never thinks about it again. So it's trying to ensure that whatever models we come up with help incentivize the installers and the operators to keep the system operating efficiently. I suppose on the electricity side then, so I suppose the main barriers are achieving the scale of the generation that we require. So we've outlined the potential in terms of the different generation typologies. So wind, solar, utility scale solar, building integrated solar, and where they could feed into the network. And then also, I suppose one of the key barriers is the supporting infrastructure to allow that renewable electricity to be absorbed into the grid and transferred to homes and businesses where it'll be used. So essentially the need for all those extra transformers, power quality equipment, grid connections, and then also the importance of avoiding excessive dispatch down. So dispatch down is essentially where things like wind turbines could be generating electricity, but they aren't because there's either not enough demand or there's constraints on the network. So there's a big role here for storage in that regard to balance the grid and provide grid services to the grid to allow us to push our targets towards higher renewable penetrations. So just to give an example of some of the analysis we did. So this is just one map we took out here for utility scale solar PV. So the kind of constraints we applied to this map is essentially grid proximity. So how close a site would be to a grid connection, which is it's a significant additional cost if you're far away from grid connection. Also avoiding any environmentally sensitive areas like special areas of conservation or anything like that. Looking for open spaces with minimal shading, obviously, where you've no shading on your PV arrays that would reduce efficiency or output. And also, so we did a digital elevation model of kind of topography of Dublin, and basically avoided areas that had a northern slope of greater than 10 degrees. So we kind of did a small bit of analysis to see what that impact would have. So if you were to install your PV farm essentially in an area that had a slope, a northern slope greater than 10 degrees, then you're looking at least twice the land area to develop your wind farm. And then we also had avoided areas that were close to woodland, rail and roads to avoid things like leaves and dust that can land on your array and cause efficiency issues. And then we also tried to prioritize areas where the land value was low. So looking at areas like landfill sites, cutaway bogs, kind of taking that low low value land and trying to use it for PV farms. And then also the kind of size of the site itself is an important consideration. So typically they say a kind of a feasible utility scale solar PV farm should be about 10 hectares, which roughly equates to about 5 megawatts. So we're kind of looking at sites of that scale. And one, I suppose, important caveat as well is that these assessments don't currently include land character assessments. So things like visual impact, which is another consideration, albeit when it comes to utility scale solar PV, that's quite small. As it's a low rise technology, which usually has some screening around it in terms of trees or bushes or whatever. So yeah, just to mention that as well.
So yeah, just discussing then the challenges and barriers for transport. Essentially, we have to try and undo 50 years worth of car-centric development in the country and in Dublin. The main kind of point is that we all need to drive far less. Electrification of our cars is necessary, but it won't be sufficient to get us to where we need to go to. So in that regard, there's going to be a lot of pushback in terms of kind of redistribution of public space that's currently given over to cars. So we need to, give that over to active travel, buses, excuse me, and people in nature. And it must be safe, must be comfortable and equitable, and these modes must be prioritized over cars. So there's kind of, at the moment, policymakers are often afraid to act. They don't think there'll be public support, whereas in fact there have been studies published recently showing that there is overwhelming public support for a reallocation of public space towards active travel and public transport, even at the cost of space for cars. And then on top of that, if you're going to be putting in sort of bus lanes and cycle lanes and everything like that, you need to enforce the regulations that are already there in terms of illegal parking, because there's no point spending billions and then having cars just parking in bus lanes, like you can see in one of the images there, or on footpaths. Looking at the kind of trends then, and the current trends in car sales, battery electric vehicles at the moment in 2022 are making up 16% of sales in Dublin. So this has to obviously accelerate if we want to get towards our 2030 targets. So, government has set a target of 840,000 electric vehicles in Ireland by 2030. Scaling that down to Dublin is about 213,000 vehicles. So we've a long way to go to get to there. And currently SUVs, which consume far more fuel and are just generally not ideal for city environments or urban environments, they are making up about 54% of sales in Dublin this year as well. So something really has to be done to tackle that as well. And then I suppose just thinking back to the sort of general principles of avoid, shift, improve. We have to look at how we're developing our city, our county, and to develop walkable neighborhoods, compact development, high density, but that doesn't necessarily have to mean high rise. And then just go back there, John. The last thing just to mention is we have this report on the top right corner there, this 5 cities demand management study, which was completed by the government, the Department of Transport last year, and it's sort of that sets out all of the actions that need to be taken in our cities to improve traffic congestion and air quality and how we get around. So we have the solutions, and it's just now a matter of implementing them. Thanks, John. So looking then at the business as usual scenario for buildings and transport. So this chart on the left, you would have seen earlier Rebecca had. So what we've added here is this green line from on the top of the graph, showing where we're currently expecting to go in terms of emissions in Dublin. So we're expecting to see, if we don't take any action, we continue on as we are, a 21% increase in emissions by 2030 and 33% by 2050. And then kind of beneath, looking at the transport emissions, we can see a 5% increase in transport emissions by 2030 is expected, and this could rise to 13% by 2050. The 2030 is that's sort of based on the NTA's own analysis that they produced this East regional model to 2028 that we were getting the outputs from. We based our 2030 on that, and the 2050 scenario here is based on assuming a linear relationship really between population growth and transport energy demand. So that's based on ESRI forecasts. So it was the same kind of standard sort of population increase that was modeled across all of the sectors throughout this analysis in the master plan. So yeah, just I suppose there on the bottom right, then it just shows the expected increase in energy demand then from buildings and transport between now and 2050, which is quite sizable. So when we're trying to come up with our pathways at 2030 and 2050, then we were looking at what targets we need to be setting. So for 2030, we're looking at a 51% reduction in emissions, and then by 2050, trying to get to net zero. So to achieve that for 2030, we'd need 213,000 EVs on the roads in Dublin, as per the kind of scaling down of national policy. But on top of that, we'd also need to reduce the distance traveled by fossil fuel vehicles by about 23% at a minimum. As part of this, we were looking at what other measures might help us along the way. So increasing public transport, so that the level of service of buses was increased by 25% over what the NTA had in their own original models. So just kind of to make a point that the NTA have done an awful lot of analysis on the Dublin region, and they've included in their models sort of everything that was in. We basically had a model output from the previous Greater Dublin Area Transport Strategy for 2016 to 2035. So we had done this analysis before the new strategy was, or new draft strategy was published in November. So just to bear that in mind, that some of these figures might vary slightly with what's proposed now with the new strategy. So then I suppose, yeah, looking at the table beneath, we were looking at the cost effectiveness in terms of emissions reductions by different modes. So it's kind of clear there that active travel is by far the best bang for your buck, I suppose, in terms of decarbonisation, in terms of investment in switching over the fleet of say diesel car to an electric bike or whatever it is. So I suppose then to just look at our 2050 targets there in our model. So we didn't have any model outputs from the NTA looking at 2050. So this was a little bit more of our own sort of idealistic sort of scenario. So we modeled there a 50% reduction in car kilometers and kind of 50% increase in bus kilometers on top of previous things that would have been included in the 2030. And also all transport was assumed to be electrified by then. So we'll have government policy states that we won't have any new fossil fuel vehicles being sold in the country past 2030. So this is in the Climate Action Plan 2021. And that there will be no NCT certificates for fossil fuel cars past 2045. So the assumption here is that everything essentially will be electric by 2050, which may not be exactly the case, but it's kind of what we were modeling in there. Next slide, please, John.
Yeah, just to touch on the pathway then for the heating sector. So contrary to what might it look like, or to what it might look like on the map, this isn't like a Republicans and Democrats illustration of Dublin. So what we're actually doing is we're modeling the euro per ton of CO2 saved based on two kind of primary technologies, one being district heating and the other being individual air source heat pumps. So you can see from the map on the left-hand side here, this is our 2030 map. All the kind of dark red areas are the areas that are most suited to district heating, and all the dark blue areas are the areas that are most suited to air source heat pumps. So we basically, for each small area in Dublin, we pitted the two options against each other to see which one came out on top. And these dark areas are the ones that there's a strong indication that one technology is better than the other, and then as the colors fade a bit more, the difference becomes smaller and smaller. So there might be certain variations in these areas might change the outlook a little bit. So what you can see here is so the red areas are the district heating areas, and in 2050, which is the map on the right hand side, you can kind of see those areas increase. So I suppose the reason for that is we're looking at, so district heating is an enabling infrastructure rather than a technology. So with infrastructure, it always tends to be, you know, a high-ish upfront capital cost, but long lifespan essentially when it comes to district heating. So the longer we look at or the longer time horizon over which we look at district heating, the better it looks. So district heating itself, you know, would typically have a lifespan in excess of 50 years, and in all likelihood in excess of 100 years. I mean, there's systems in New York that have been installed in the 1880s that are still operating today. So, yeah, that's what that kind of explains the maps. And then in the middle there, we have just kind of highlighted, so that we've got a national target of 2.7 terawatt hours to be for, you know, buildings to be kind of residential and commercial buildings to be heated by district heating by 2030. So we just kind of did a map to see, you know, if we picked out the, you know, the kind of most favorable areas for district heating in the county, you know, what areas would those be to achieve that target. Then I suppose on the kind of heat source side as well. So as I said, district heating is an enabling infrastructure. What allows you to use things like waste heat from you know, data centers, from power stations, you know, from rivers. You can, you know, use heat pumps to increase the temperature for district heating networks from all these different sources. So we've identified about 520 sources in Dublin, and I suppose the total available heat from that is about 3,500 megawatts, which is enough to heat roughly 1.6 million homes, which is, you know, is far in excess of the number of homes in Dublin. So this kind of just gives an outline of the heat source opportunities, and there's a link on the bottom left there to an online version of this map, which we've also posted. And to just give a breakdown of those, so this is our 2021 breakdown. So we've also done it for 2030 and 2050. So you can see currently one of the main sources of heat are power stations, but that drops off significantly by 2030. And in that period, the data center slice gets bigger, and there's like an introduction of new things like curtailed electricity from offshore wind and things like that. So even though these power stations drop off significantly, the total kind of heat source availability doesn't drop off that much, really, in reality, across the kind of lifetime of the plan. Just on the kind of electricity pathway then, so I guess the main takeaways from this are that the utility scale solar PV provides the best value, I guess, in terms of cost of carbon saved, with, I guess, building integrated PV being the highest cost in terms of cost of carbon saved. And I suppose the biggest opportunity for Dublin is the offshore wind opportunity, which you know, is very significant in Dublin. And what we've also put in here, the kind of grayed out row, is basically the role of, you know, the other kind of sectors in supporting this, the use of this electricity. So basically, it's the amount of wind that would not have been used were EVs and district heating not already installed. So it's basically how much energy they're absorbing and making use of at different times of the day when the wind isn't blowing. Rebecca.
Yeah, thanks, John. So throughout this master plan process, the team has been considering wider economic and social benefits of the low carbon net zero pathway. So by making use of low carbon technologies and increasing renewable energy, this can provide multiple opportunities. So like, so for example, using indigenous sustainable sources to meet Dublin's energy needs. This way, the region can reduce its reliance on fossil fuel imports, which is very much needed at the moment. And also by making use of low carbon local solutions to reduce emissions, the region can improve its air quality and can also help to generate more employment for Dublin's citizens. So this employment generation in the low carbon clean energy industry would mean that a number of citizens would need to be upskilled for new roles. And by ensuring that citizens are actually upskilled in the area of energy generation and low carbon technologies, then this means that we can ensure that there's a more just transition for the Dublin region's citizens. And next slide there, please, John. So in the next slides, we'll be seeing the pathway to net zero emissions that are that's proposed by this master plan. So the master plan will seek to remove from our atmosphere a total of 8,240 kilotons of CO2 by 2050, which can greatly improve air quality and reduce air pollution as well. So the Dublin region can potentially generate 14,780 gigawatt hours of renewable energy generation by 2050. And this increase in renewable energy can greatly help reduce the region's heavy reliance on fuel imports and also be making use of indigenous renewable sources. Besides that, the renewable energy can help to decrease energy costs for the region's citizens. And then looking at the shadow price of carbon. So the shadow price of carbon is essentially the estimated abatement cost for Ireland to remove emissions from the atmosphere. So if we were to apply the shadow price of carbon to the total avoided emissions, so looking at renewable energy generation, low carbon technologies, building fabric upgrades, and also transport improvements. So over the lifetime of the master plan, this can result in a total avoided cost of over 24 billion. And this avoided cost would be much better invested in renewable sources of energy, energy efficient homes and heating options to reduce emissions and also to reduce citizens' utility bills. In the master plan, we've also identified areas that are at risk of energy poverty. So that's the map on the right there that shows the areas in red on the map. So these areas should be prioritized for energy efficiency upgrades and investment schemes. So really trying to finance energy efficiency measures that are needed to alleviate energy poverty. And by investing in clean energy projects, besides helping improve air quality, increasing renewable energy generation, reducing emissions, we can also help improve the economic status of the region. And this would be through the generation of local jobs to facilitate, I suppose, this emission reduction that's needed. And from this master plan to 2050, it was found that direct jobs would likely increase by over 182,500 by 2015. Next slide there, John, please.
Thanks, Rebecca. So just to kind of bring it all together, this chart sort of shows the gap to where we need to get to and what technologies or what we can use to get there. So yeah, if we look at the 2030, you can see the blue dashed line is where we need to get to 50% reduction. And we have, yeah, basically ranked all of the options here in terms of the highest or lowest cost in the order here. So transportation, we can see obviously a significant reduction from transport, and the largest impact here is from offshore wind coming onto the grid in Dublin. And then district heating, heat pumps will have a significant impact as well. To 2050, we can see, yeah, again, by far the biggest impact is going to be offshore wind. And then this will be followed by district heating, by storage then as well, which will become quite significant when you have that much offshore wind coming online. That obviously the wind doesn't always blow when you need it, so we have to figure out ways to store that. And transport as well will hopefully see a significant decrease in transport emissions to 2050. Just at the, sorry, John, just the one point just to make here, you can see at 2050, it actually goes below zero. Now this isn't to say that we're going to be extracting carbon dioxide from the atmosphere, but it means it's more to do with the energy side of things, that we'd actually be generating more energy in Dublin than we're using. So we'll be exporting that energy to the rest of the country or to other countries if that's the case. But just so just a bit of clarity on that there. Thanks, John. So kind of putting some numbers on, just what was in the previous chart there. So if we carry out all of the recommended actions, we could reduce emissions by 4,100 kilotons of CO2 by 2030, and double that to by 2050. The amount of electricity that could be generated through renewables in Dublin could be almost 15,000 gigawatt hours by 2050. So I suppose through all these actions, you know, it shows that it is possible to meet our 2030 and even exceed a 2050 target. It'll be very difficult, but it is technically possible. And yeah, that would become a net exporter of energy by 2050. And I suppose then, yeah, looking at the energy costs from bringing on all this renewable energy technology into the county, you know, whether that's wind, solar PV, or whatever it is, you know, that could save or reduce our energy costs by about 500 million per year. And then I suppose on an overall societal level, looking at the avoided costs, so this is kind of avoided societal costs of over 24 billion when you apply the shadow price of carbon. So that's sort of external costs in health and well-being and all these other jobs, everything else kind of like that. That's not just energy costs. And then, yeah, I suppose looking at, as Rebecca was talking about earlier, the number of jobs to be increased potentially by 182,000 by 2050. Next slide, please. So I think just it's important to acknowledge, I suppose, that we are very much engineers looking in this in an engineering way. So there's an awful lot of the softer side of actions and kind of, you know, it's not all just about you know, installing infrastructure and looking at the numbers. Like there's this kind of idea of creating a healthier city and county with more comfortable homes, you know, cleaner air, quieter streets, and more space for nature and people. Like, so it's not just, obviously we're focused on the energy and emissions, but there's a lot more that needs to be looked at in terms of, you know, trees. And, you know, trees are you know, they reduce the temperature. So if you have more green, then maybe you don't need as much energy demand in air conditioning, that kind of stuff. So there's a lot of overlap there, which has to be sort of, I suppose, further explored. So then I suppose just running through some of the key recommendations from our analysis. So we've kind of gone through each of the main sort of headings here, and then in terms of the kind of energy planning, buildings, transport, heat, electricity, and so on. So and then in terms of energy planning, what we'd like to see is guidelines made available to local authorities for local level energy planning. And we'd also love to see energy planning become a requirement for kind of implementation of local level energy plans, so to sort of enable this kind of development of pathways and long-term commitments to a low carbon future. In terms of building energy efficiency, like the number one thing here should be, you know, trying to alleviate energy poverty. So we should be prioritizing energy efficiency upgrades in those areas that have been identified as being energy poor. And then I suppose, yeah, we need regulatory solutions to tackle this issue of split incentives where, landlords aren't necessarily seeing the benefit from upgrading the properties because the tenants are paying the bills. So that's sort of something that needs to be really addressed. Next slide, John. In terms of heat, yeah, using this master plan, I suppose, as an energy or as an evidence base for zoning for district heating, and then also ensuring that there are requirements in place for new buildings in these areas that future-proof them so that they can connect to a district heating system once it becomes available in their area. Also then looking at the building regulations to ensure that low carbon heat sources are treated fairly, which isn't necessarily always the case at the moment. And then, yeah, making financial support more easily available for these low carbon solutions. In terms of electricity, yeah, we just need to support the development of these generation assets, if it's offshore wind or onshore wind or PV, where it's suitable, and enabling the development of the infrastructure that's required to bring these projects to reality, to actually see them connected to the grid. And then I suppose looking at options to integrate PV into buildings, particularly where there's the demand and production profiles match up. Looking at transport, I suppose the main point is there's 550,000 cars in Dublin at the moment. If we just electrify all of them, it's not going to solve the problems with congestion and various other kind of societal issues around car dependency. So we really need to substantially reduce the number of cars and the distance travelled by those cars in Dublin. And to 2030 specifically, we really need to focus on active travel and buses. We have Metrolink, which is going to be, beyond 2030, any kind of major rail projects apart from the Dart Plus upgrade, that's all kind of going to be post 2030. So in the short run, that we really have to focus on active travel and buses. There's obviously issues with local authorities not being able to reallocate road space particularly easily. So, the implementation of trial schemes and also then enforcement of road traffic regulations really needs to be stepped up. So, yeah, I suppose just from Codema's perspective on how we'd like to see the master plan, this work develop and kind of be brought forward. So, yeah, essentially we've kind of set out this kind of spatially led pathways to 2030 and 2050, and kind of the next step is the zero to scalar project, which was mentioned earlier, which kind of will bring, I suppose, a number of different stakeholders, as broad and diverse a group of stakeholders together to try and plot out how we will actually achieve what needs to be done. And then hopefully that'll kind of lead to implementation of these projects at scale. Next slide, please, John. So yeah, essentially the Zero Together project it's a project Codema has been working on. It's a European project with a number of other kind of partner cities doing similar projects across Europe. And it's looking at basically removing fossil fuels from our society by 2030 or 2050. Next slide, please, John. So essentially what we're trying to do with this project is the Dublin Regional Energy Master Plan, which serves as evidence-based, and we collaborate then with people from a variety of different sectors, and formed a transition team with kind of front runners, I suppose, from various different sectors and kind of areas of society. And we're trying to bring it together now. The next step would be to have really strong public participation in this process. We've already had a public survey earlier this year, and now to try and build on that and to actually hold a citizens jury for Dublin is kind of the next step. So I guess, yeah, just to summarize, yeah, we I suppose in Dublin we have the potential to achieve the targets, and we can reduce costs to society by up to 24 billion. We can, I suppose, as I said, like active travel is the most cost-effective way to decarbonize transport, and can really bring transformative societal benefits for Dublin. And yeah, I suppose kind of going forward, like Codema isn't intending to do all of this on their own, so we have to work with the Dublin local authorities, and so we are kind of engaging with the local authorities with the results and trying to bring this pathway forward. Next slide, John. So yeah, just I suppose these are some of the links to some of the resources we have. So our maps are available there online, script, and some of the apps that we have developed as well. So these slides will be shared afterwards, so you can check out those in your own time. And then, yeah, if you have any further comments or questions, yeah, our contact details are there as well. So thanks for listening.
And thank you so much for that, guys. I personally have heard this presentation several times already, and it never fails to impress me in terms of the breadth of research and the amount of fantastic insights. And by the looks of it, our audience agrees this morning, because the questions have been flying in. We've been furiously trying to group them together behind the scenes to get through as many as possible. But just to say, if we don't get to your question this morning, feel free to email us and we can follow up with you directly afterwards. We'll be sharing the contact details at the end of the presentation. Owen just had them up there as well. So to kick off with the Q&A session, actually it's for you, Owen. The first question from Robert Moss. So the question is, how are the transport emissions by vehicle type calculated?
Okay, yeah, that's a good one. So yeah, we used two kind of resources for this. For the car fleet, we based that on some research that had previously been done by UCC. They have a car stock model for a national level. So we basically applied that kind of, the results, the outputs from that model to, we just scaled it down to Dublin and assumed that the kind of the car stock across the country was all the same. In terms of heavier vehicles, then we looked at well, for public sector, like, so public buses and things like that, we used available data where it was, where there was data available, we used that, and we also used the COPERT tool, which is a sort of European tool for national inventories to kind of, for countries to develop their own national figures. So yeah, those are the main sources for that.
Brilliant, great stuff. So the second question we have here is from Zoe Obenham. She's asked, how can a local community organise a local energy plan? We're creating a local greening strategy, and there is a lot of interest in a local energy plan, especially around the Inchicore, Kilmainham area. So I might direct that to John or Rebecca, if you want to take that.
Yeah, sure. Go ahead, John.
No, you go, Rebecca.
Yeah, so I suppose, yeah, there's these sustainable energy communities. So that might be a way of creating a local energy plan. So sustainable energy community essentially would be looking to gather a community in which everyone works together to develop a sustainable energy system. So to do so, they would aim to be as energy efficient as possible to reduce their energy use. So that would be using renewable energy, using low carbon technologies as well. So that would be a way to, I suppose, to start creating a local energy plan. So that would mean a local energy plan would mean getting the evidence-based master plans, so understanding what the energy demands and emissions are in the area, taking into account the local factors, so say the building fabric in the area, understanding the opportunities to decarbonize, and also ways to increase renewable energy, and being able to identify those key actions that can be taken to reduce demand and emissions as well.
Yeah, that's brilliant. Thanks, Rebecca. So we have two questions in here from Sarah Zimmerman. So the first one being, are ecological and biodiversity related issues taken into account as part of the planning? And the second question is, did big tech companies like Amazon, Microsoft, Google, and Facebook engage on the issue of data centers as part of this plan? So I might go to you, John, if that's okay, to answer those.
Yep. Yeah, I suppose on the first one, I suppose it's important to say that this is an energy master plan. So those factors were considered, I suppose, in terms of where certain technologies could be located. For example, I mentioned the special areas of conservation and those types of areas that we've avoided in kind of all the technology, or all the kind of large scale technologies that we've been looking at. So yeah, I mean, there's definitely more that could be done on that, but yeah, I suppose the scope of this work was energy, but yeah, that's also a really important area. And I suppose in terms of the data center companies, so some of the data center organizations and AirGrid were involved in the development of the plan in terms of helping us to estimate demands from these centers and also where they're located. So they have been engaged on that side of things.
Brilliant, great stuff. So another question that we have in here is, do you think Ireland should track BER rating of protected structures to provide baseline data on energy efficiency in heritage buildings? That's an interesting question. So Rebecca, would you be happy to answer that one?
Yeah, certainly. Yeah, so I think it certainly would be good to be able to track protected structures and understand their, I suppose, their energy demands and their how efficient these structures are. Even if it might be difficult to say upgrade or to retrofit these structures, it would still be good to get an understanding of the demand and the emissions, I suppose, that are emitted from these structures.
Brilliant, great stuff. Another question we have in here is from Peter Hamilton. So if our total national grid capacity nationwide is about 30,000 gigawatt hours and Dublin's heating alone consumes 10,000, the transition to sustainable electric energy requires an enormous increase of our national grid capacity, ? So that's asked as a question. So I might ask John, actually, if you're happy to answer that one.
Yeah. So definitely there will be a cost of grid upgrade associated with electrifying heat. So as I mentioned, we've included that in our models as a sort of a euro per kilowatt increase of electrical demand, which is based on kind of standard costs provided by ESB. I suppose the thing worth noting is that we've also looked at district heating, which can have a lower impact on the grid for a number of reasons. One being it's more efficient on the heat production side because you can use things like waste heat sources rather than just heat from the air. It connects into the grid at a different point, so you're essentially bypassing large sections of the grid that would have had been upgraded. And also the fact that you can have this kind of really cost-effective large-scale thermal energy storage, which you can use for shifting loads into times of the day when there's less stress on the grid. So that kind of helps, I suppose, optimize the amount of grid upgrades that are required. So you might not need as much grid upgrades as a result of those kind of three topics, I guess. So yeah.
Yeah, brilliant. Thanks, John. Rebecca, I have one here for you. Could you please clarify the steps you took to identify the gaps to targets from the baseline emission inventory for the different sectors? Excuse me. For the different sectors.
Yes, certainly. So I suppose the first step was to identify our historical emissions, which was a bit difficult because I suppose our historical emissions are gathered at a national level, so that would be through the EPA, so we wouldn't necessarily have that breakdown at a local level or at a regional level for the Dublin region. So we, I suppose we downscaled the EPA inventories for the Dublin region. We looked then, so that goes as far back as 1990. We then looked at our current energy demand and emissions that was broken down by sectors, by the different sectors. From that, once we grouped all the emissions, I suppose at the time of writing, and still at the moment, we don't necessarily have a sectoral emission reduction, an emission reduction for each sector. So what we did was we grouped all the emissions for 2021, looked at our 2030 targets and 2050 targets, and then I suppose then we looked at our gap to target. So looking at the 2021 figure, our 2030 reduction figure, and our 2050 net zero energy related emissions figure then.
Great stuff. Thanks, Rebecca. So a question in here from Cormac McKay. So he says, despite a report on shared mobility from the ITF and OECD, Dublin currently has no free floating car sharing services and very few electric car sharing cars. And services are much more expensive here compared to our EU neighbours due to lack of grants and incentives. This area of transport has been abandoned by both national and local government. What do you think we could do to improve this neglected sector? Owen, I might go to you for that, to comment on that.
Yeah, it's an area, I suppose, that was not really examined through the master plan at all. Yeah, free floating autonomous vehicles, we decided it's probably too far out. It's untested technology at the moment. So yeah, that was sort of why we didn't really go down that route at all.
Okay, no problem. Great stuff. Then John, just a question on one of the maps that you had up there. If you could just explain the different colours on the MVA map and what they mean. Is red less available electricity capacity? And also if you could say what MVA means, just to explain.
Yes. Yeah, so yeah, on the map, the red areas are the areas with the less capacity in them. It's probably important to mention as well that that those maps are based on basically what's already connected. So if there's certain new connections that are being planned or quoted for, they're not currently in that information. So that's just an important thing to state. And then the MVA is the megavolt amperes. So it's essentially it's just a measure of electrical capacity essentially. Yeah, I won't go into power factors and all that, but it's a measure of capacity.
I go on and know. Perfect. No, that's great. Thanks, John. So a question here from Connor Malloy, I think it is. What provision has been made in the plan for goods and services transport, for example, food and engineers, etc.? Any chance of a congestion charge? So I'll go to you, Owen, for that one.
Thanks, Katie. So yeah, I saw that one coming in from Connor. Yeah, I suppose we were looking at measures to decarbonize the freight sector. So e-cargo bikes, electrified vehicles, and also shifting some of the freight to from road to rail. So I suppose those are the main things that we were looking at. There was a second part of that question. Sorry.
Yeah, any chance of a congestion charge?
Oh yeah. Yeah. So I suppose as part of that 5 cities report that the Department of Transport produced last year, that is one of the actions mentioned in that report, and yeah, definitely, I think it's something that Dublin needs. So obviously we would just be supporting that policy and requesting that it's kind of implemented as soon as we can.
Okay, great stuff. And I'll hold on to you there, Owen, for another question. So Dennis O'Callaghan just asked, is the aviation industry included in this analysis?
No. So yeah, simple answer. Aviation and maritime are not included because they're not part of the national targets.
Great stuff, thank you. So a question in here just around ambition. So why are these unambitious years of 2030, which is 8 years away, and 2050, which is 28 years away, being picked as a goal? You know, can we not do better than this? What is the main delay? So I might actually just throw that out to the panel. Whoever wants to pick that one up, maybe John or Rebecca, if you want to start.
Sorry, I missed that one, Katie. Sorry.
Yeah, no problem. So the question is basically around just our targets of 2030 and 2050, and you know, why are these our targets? Can we not do better than this? And what is the kind of main delay for action, I suppose?
Yeah, why are they our targets? Yeah, I'm not sure if we can answer that one. It's probably different organizations that look after those. But I suppose what we can say is that hopefully, I suppose when you're looking at Ireland, obviously there's a lot of, it's, you know, a broader area. So there's, it's a lot bigger piece of work, I suppose, to come up with specific technologies for specific areas. So I think probably the work that we do obviously can feed back into that now. And, you know, obviously we've recommended that other areas also do their own local energy planning. So it's, I suppose it's getting that feedback loop working to say, you know, to question, I suppose, maybe the targets and what they could be and what's realistic. So yeah, it's a process, I suppose, and we're hoping that what we've done will feed into that.
Yeah, and I suppose even though some targets might seem unambitious, or it might seem like a lengthy timeline, that doesn't mean that there's anything stopping the region from being more ambitious, I suppose, and being leaders in the area. So yeah, having those lengthy timelines might be a way of, for example, making sure that you have the right infrastructure in place, so you're ready to meet your 2030 targets and 2050 targets. But that doesn't mean that we should still just be aiming for 2050. There's nothing stopping the region from being more ambitious, I suppose.
Yeah, that's a really good point, Rebecca. Thank you. So we've just grouped two questions here. So yeah, actually they're for you again, John. You're in high demand. So since there is so much heat available, can some of that be turned into electricity? And then a similar question would be, is waste heat, for example, from data centers, recognised as a renewable heat source in Ireland? So that kind of, yeah, that question.
Yeah, so I suppose the heat sources that we've identified are kind of lower grade heat sources, what we'd call low exergy heat sources, which aren't really suited for generating electricity, but work really well for heating buildings and providing hot water. So when you're generating electricity, essentially what you're trying to do is generate steam to turn a turbine. So the temperatures we're looking at there can't provide that. And sorry, there was something about waste heat as well. Sorry.
Yeah. So, is waste heat from for example, from data centers, recognised as a renewable heat source in Ireland?
Yeah. So we're actually working with the SAI on this. So due to the fact that district heating hasn't been widely adopted in Ireland till recently, there's certain barriers that exist just due to the fact that it wasn't considered before now. So one of them is making sure that it's you know, that it's considered on a par with renewable, which is consistent with the Renewable Energies Directive from the EU. So yeah, we're kind of working towards that to make sure that that's the case.
That's great. Thanks, John. And I'll just hold on to you for one more question here. How are the offshore wind costs calculated, kind of megawatt hour costs?
Yeah, so that's so essentially what they are is kind of the kind of complete cost of install and kind of their likely generation over their lifetime. So a lot of it was based on kind of literature review from governmental organizations around Europe, which all have developed a certain euro per megawatt hours. So the costs we have are slightly different from what's being experienced in Ireland at the moment, where it's higher. And I guess a lot of the kind of cost differential in that is down to, I guess a bit more efficiency in the system in terms of planning and consents and things like that. So I suppose we're kind of looking out across that kind of 30-year horizon and assuming that those systems will be streamlined to help reduce the costs and in line with what's expected in other countries.
Mm-hmm. Okay, brilliant. A question for you, Rebecca, actually. Where can we find more information on local area energy plans and policies? That's coming from you.
So yeah, I suppose through some of the work that Codema has done, so we've created baseline emission inventories for the local authorities, and we've also created step-by-step guides on how to create those inventories. Then we also have our spatial energy demand analysis, so that essentially looks at spatially mapping. It's like similar to a mini master plan, but just the evidence based. So spatially mapping out all the energy demands for each local authority area, and that also gives some insight into the methodology and I suppose how to actually generate CEDA. Yeah, so I think those would be good sources, and then the master plan as well. This master plan would be a good source for local energy plans.
Great stuff. Thanks, Rebecca. So we have about 4 minutes left, so we might just take 2 more questions. So yeah, a question in here from James Carton for you, John, actually, if that's okay. What do you see for the role of green hydrogen in this Dublin Region Energy Master Plan, considering hydrogen buses are already on Dublin's roads and the existing plans for a large number of large electrolyzers in the Dublin region?
Yeah, so I suppose we've kind of included hydrogen in the kind of decarbonisation of gas. So in our assumptions, we've assumed a certain amount of biomethane and a certain amount of hydrogen. Now, considering it in a more localized way, we're not thinking about the whole network. There are opportunities in Dublin in terms of, the port, because the renewable power generation is going to be intermittent, the possibility of running turbines on hydrogen when you need them. So kind of dispatchable power, as we call it. So having the control to generate electricity whenever you want it when you don't have the renewables. So that's probably the role. And we're actually doing a study as well in the Pool Beg area, where we're looking at the possible integration of offshore wind electrolyzers, the electrolyzers providing green hydrogen to maybe the port or the power production, or other industrial sites around Dublin where they might need high temperature heat for processed steam and things like that. But also looking at the electrolyzer, and the electrolyzers also give off a lot of waste heat. So around 30 or 40% of the electricity that's consumed is actually converted into heat. So trying to feed that into the planned district heating network. And also looking at things like as I mentioned previously, the kind of offshore wind farms, reducing the curtailed energy from those by having either large heat pumps or electric boilers connected to large scale thermal storage vessels. So that provides a kind of a cost-effective battery essentially for the system.
Brilliant, great stuff. So we might just go for one final question. Owen, do you think the 20% discount on public transport was enough? Should we have free public transport at point of use?
I would argue, and there's international evidence to back this up, that free public transport is not actually good climate policy, that you end up with people shifting from walking and active travel to public transport rather than getting people out of cars. So in that regard, the international evidence seems to suggest that free public transport is not necessarily the way to go, that you should rather be spending the money you take in on fares on putting on more services, more frequent and better services.
Great stuff. Thanks, Owen. So we might just finish it up there. Just to say again that the recording and presentation will be shared with you all in the next day or two. A big thank you again to the master plan team for all their great work that they've done over the last few years. As I said before, if you do have any follow-up questions or comments for our team, please do get in touch. The full report and summary brochure are now available on our website. We'll also be sending around a link to these resources with the recording. With that in mind, just to say a big thank you to our communications manager, Suzanne Fitzpatrick, who has put this launch together and has done Trojan work behind the scenes in promoting and launching this fantastic piece of work. Thanks again to SCAI for providing the funding to be able to carry out this research through the RD&D programme. And of course, thank you all so much for joining us this morning and for your engagement and questions. Thanks very much. Take care.